Okay, this is specifically for homework 4.5. I decided to cut it a little bit short since the last video was running a little long. And so this video will cover transition metals, which some of my students struggled a little bit with today. And so again, this is for homework 4.5. Okay. All right, so 4.5, we talked about naming ionic compounds with transition metals. And the important thing to note, again, I have the periodic table here to the right. And the reason I put it on here is because a lot of students tend to waste a lot of time with looking for elements on the periodic table. And so first you have to know what you're looking for. So what I like to do when I first get a blank periodic table in order to take a test, I like to fill out my periodic table. Okay, so I make sure that I've identified my regular metals, meaning I know their oxidation number, it's not going to change. So I'm going to do that in green. Okay, so my metals are right over here. Oops, I'm not supposed to get hydrogen in there. So here's metals, and then again, metals, okay. And then I like to identify, so these are, I also like to identify my non-metals. So I'm going to do that by highlighting them in purple. So again, everything to the zigzag line with the exception of hydrogen. Hydrogen is to the left of the zigzag line, but that's also a non-metal. Okay, so I'm going to trace it, making sure that we know that these are my non-metals. Okay, and so I'm going to label them real quick. Okay, and then in green, maybe I'll make myself a key. So these are my metals. Now, when I talk about transition metals, I'm basically talking about everything in between the regular metals and non-metals. So I'm going to go ahead and highlight those in orange. Okay, so I'm going to trace them in orange. And here are my transition metals. Okay, they'll be found in groups 3 through 12. All right, once I'm done with that, I also like to identify oxidation numbers or states. And you need to just memorize that information, okay? And so in this case, we know that group 1 will have an oxidation charge of +1. Group 2 is +2. And if you look closely, you'll have a pattern. Group 13 will be +3. Group 14, well, that one can vary a little bit. Sometimes it can be plus or -4, or it can be +2. Group 15, again, we start going down. Now we have -3, -2, -1. And my noble gases, they're happy, so they have a 0 oxidation number. Okay. All right, so if I've done that, because you need to know that information for your transition metals. Okay. And again, my transition metals, I forgot to label them. I'm going to label them. My transition metals are going to be here in the middle. And these are different because these transition metals, they have more than one oxidation state. That's different from everything else that we've covered so far. When we talk about groups 1, 2, 13 through 18, those oxidation numbers do not change. Okay, well, with some exceptions, but we're not there yet. Okay, but transition metals, those vary. And so that's what we're going to try to figure out today. So again, with the last tutorial, with the last homework assignment that I showed, I said, well, I like to identify my obvious ones first, and I like to complete all of my covalent, all of my ionic, all of my polyatomic, and all of my transitions together in groups, okay, rather than jumping back and forth within rules. So the easiest one to take care of for me is polyatomic ions, because I can identify those right away. So I'm going to identify those, and again, for polyatomic ions, let's see, what color can I use? I'm going to use blue for polyatomic ions. For polyatomic ions, that means you're going to be using this table over here. Okay, and that's how I know usually when my students know what they're doing or not, because they're trying to answer or write down names for polyatomic ions without the list of polyatomic ions, which is almost impossible. So again, the fastest and easiest way to identify your polyatomic ions is you're going to have 3 or more elements in a formula. So I go all the way 1 through 5, they all have 2. They're all binary compounds because they only have 2 elements. But then the first one I bump into is number 6. You have 1, 2, 3. So this one, right away, I know it's a polyatomic ion. Or it includes a polyatomic ion. My next one is going to be 13 because, again, it has 3 elements. Can I keep going? And the most obvious one is probably number 17 because this one has 1, 2, 3, 4 elements. Okay, so I'm going to answer my polyatomic ions, and again, I make mistakes, so maybe I skipped one, but I will find it because I always, try to go in order, and I always look at my reference materials. So again, for my polyatomic ions, my rule, here's my polyatomic ion. The only polyatomic ion that you'll see listed first is hydrogen, okay? All the rest will be listed second. So I looked at my list for my polyatomic ions, and I locate SO4, and I see that it is sulfate. So again, the rule is to always write your metal first. In this case, it's iron. And then you write the name of your polyatomic ion, which is sulfate. Okay. All right, next one. I have, that was SO4, right? Okay, so yeah, so then I go down to my next one. I identify my polyatomic ion. This one's SO3, so be careful because it will change the name. It goes, now it is, I'm dealing with sulfite. So this one is sodium sulfite. Okay. All right. And my last one, again, my polyatomic ion is listed after my metal. And if I go up to my list, I find it over here. And this one is called acetate. So again, my metal is listed first. In this case, it's potassium. Acetate. Okay. All right, so then I got those out of the way. The next compounds that I like to work with are going to be my nonmetals, okay? Again, because they're all going to be enclosed within this purple area to the right of the zigzag line. So they're a little bit easier for me to identify. So I'm going to go back to my purple, okay? And the first one that I see is sulfur and chlorine. And I know that this is a covalent compound because, again, they're both to the right of the zigzag line. I'm going to keep looking. I'm going to keep looking. Cr, no, that's chromium. I'm going to keep looking. Okay, next one that I find is nitrogen and iodine. Nitrogen and iodine, again, they're to the right of the zigzag line. And it looks like that's pretty much about it. Okay, so I'll have to come back in case I find another one. So again, my covalent compounds, these are the only ones that will have the prefixes. So in this case, sulfur does not have a prefix. I mean, it does not have a prefix because there's only one sulfur, so we don't need a mono. So it's just sulfur. But then I do have 4 chlorine, so it'd be tetra. I'm going to use the root word of chlorine, which is chlor. And I'm going to change the ending to "ide." So here we have sulfur tetrachloride. My next covalent compound, again, made of 2 nonmetals. We have N for nitrogen. There's only 1 nitrogen, so there's no need for a prefix. Nitrogen. And then we have iodine. So there's 3 iodines, so it's going to be triiodine. And I'm going to change the ending to IDE. Now, in this case, don't get too stuck on if it's 2 I's or just 1. It's probably triiodide, okay? So I won't be deducting for that if you include 2 I's in there because I tend to do that sometimes too. All right, so then I got rid of my covalent compounds already, and I got rid of my polyatomic compounds. So next, I want to do ionic compounds, okay? And I know that if it's ionic, they're going to be within this green area, okay? It's either here or here. So these are a little bit easier to find. So I look for Ni. Nope, it's not there. So that automatically means that that's transition. Copper, nope. So I'm going to go ahead and start listing those as well. So because nickel is found in groups 3 through 12, it's a transition metal, and nickel is actually in group 10. I have Cu. I know it by heart. It's found in group 11, so that's a transition metal. I have Fe. Fe is found in group 8, so that is also transition. Cu, again, back to Cu. That's group, what did I say? 11. I have Sn. Sn, well, Sn is actually here. So that's a regular metal. So that would be forming an ionic compound. So Sn, I have ionic. And A, sodium, is group 1. So that's a regular ionic compound. Cr, chromium. If I look for it, I see chromium is in group 6. So this would be a transition metal. I look for Mg, that is in group 2, so right away I know that I'm dealing with an ionic compound. I look for Mn, manganese, and manganese is in group 7, so I'm dealing with the transition metal. Again, manganese, transition metal. Au, or gold, that one is found in group 11, so it's a transition metal. Pb is found in the green area, okay, right over here. So Pb is actually creating an ionic compound, okay? So it would be ionic. And my last would be Co, which is cobalt, and cobalt is found in group 9, so that would be a transition metal. Okay, so again, I'm going to name all of my ionic compounds first because those are pretty easy for me, and that way I can stay in the same frame of mind. So Sn, in this case, the name is tin. So tin sulfide. My next one, I have sodium sulfide. No prefixes because we're talking about ionic compounds, a metal and a non-metal. But what is changing is the ending or the suffix of the second of the non-metal. Next, we have magnesium bromide. Okay. Next, we have lead oxide. Okay, we have lead oxide. Okay, now I can go to my transition metals. Okay. Now, for transition metals, you have to know the oxidation numbers, okay? We have to figure them out. And so if we look at fluorine, which is my non-metal, and I go back to my periodic table of elements, fluorine it has an oxidation charge of -1. So at the bottom, each fluorine atom has a charge of -1. In this case, I have 2 fluorine atoms, so overall for this F2 is a charge of -2. Now my nickel, in order for this compound to have a neutral charge, my nickel has to be a +2. I only have 1 nickel because there's no subscript, so we can assume that there's only 1. So +2 divided by 1 means that every nickel atom has a charge of +2. So again, my rule is I'm going to write the name of my transition metal, which is nickel. The oxidation number for every single nickel ion is what's going to be determining my Roman numerals. In this case, it would be 2. And then I'm going to follow regular ionic rules, which would be nickel to fluoride. Okay, I know that one's a little in the way, so I'm going to go ahead and erase this so it won't be too much in the way. Okay. All right, and so next we look at the next one. I know that every single oxygen has a charge of -2. I only have 1 oxygen, so overall this has a charge of -2. In order for this copper to cancel out that -2, this has to be a +2. But I have 2 coppers, right, because of the subscript. So in this case, +2 divided by 2 means that every single copper atom has an oxidation number of +1. So in this case, my name would be copper, Roman numeral 1, oxide. Okay, number 4, I have iodine. I'm going to look to see my oxidation number, and it's in group 17, so iodine has an oxidation number of -1. I have 2, so this is a charge of -2. Again, my iron has to be +2. Have 1 iron, which means every single iron atom has a charge of +2. So in this case, I have iron, 2, iodide. Okay. Next, I have bromine is my nonmetal. So Br is also found in group 17, which means it has an oxidation number of -1. I have 2 bromines, so that means that that has an overall charge of -2, which means that copper has to be a +2. I have 1 copper, which means each copper has an oxidation charge of +2. So in this case, my name is copper 2 bromide. All right, next one, I have selenium, Se, is my nonmetal. Selenium is found in group 16, so it has an oxidation charge of -2. Each selenium atom has an oxidation number of -2. I only have 1 atom, so this is charge of -2, which means chromium must be +2, which means every single chromium atom, there's only 1, has to be +2. So this would be chromium 2 selenide. Sounds a little weird. Okay. All right, next we have manganese and oxygen. Oxygen has an oxidation number of -2. There's only 1, so this is -2, which means each manganese is +2. There's only 1, so every single atom has a charge of oxidation charge of +2. So this would be manganese 2, and then oxide. Because again, I'm following ionic rules for the rest. All right, next I look at selenium. Selenium is in group 16. So every single selenium has an oxidation charge of -2. I have 3 in this case because of the subscript. So overall, this has a charge of -6. This manganese, in order for it to cancel out that -6, has to be a +6. But I have 2 manganese, so that means that 6 divided by 2, every single manganese has an oxidation charge of +3. So in this case, my name is manganese 3 selenide. Okay, and this is exactly what we mean by multivalent. And so if you notice closely, in this case, manganese, every single one had an oxidation charge of +2, and here it changed to +3. Okay, and that's where transition metals are it can be a little tricky. All right, number 14, I look at iodine on my oxidation, on my periodic table of elements. It's in group 17, so it has an oxidation charge of -1. There's only 1, so there's my -1, which means gold has to have an oxidation number of +1. There's only 1 gold atom, so that gold atom has an oxidation number of 1. So this would be gold 1 iodide. Okay, my last problem, again, I have chlorine. It's in group 17, so it has a charge of -1. There's 3. So these Cl3 has an overall charge of -3. Cobalt, in order to cancel out that -3, has to be a +3, but there's only 1. And that means that every single cobalt atom has an oxidation number of +3 in this formula. So my name would be cobalt 3 chloride. Okay, and if you have any questions, please feel free to come in for tutorials.